Hi everyone, welcome to Domain 7, Infrastructure and Networking. So this domain will cover overall infrastructure footprint and network security. So IaaS, Infrastructure as a Service, refers to compute, network and storage resource pool. In this section, you will be more covering towards how you actually secure infrastructure and networking with different architecture. Let's start. So this one is seventh domain out of the 12 domains covered in CCSK. It's infrastructure and networking. In this domain, we will talk about areas and techniques used in securing cloud infrastructure, what is cloud network fundamentals, container networking, apply zero trust techniques to secure cloud infrastructure networks, and managing security for service edge. So the last topic is something new we'll cover. I have few slides for you to manage and understand service edge. Cloud security infrastructure. So cloud infrastructure is actually when you're provisioning fundamental resources that goes EC2, VPC, endpoint networks, and then as a customer or a cloud customer, you have to design and build the architecture to the services provided by the service provider. So in IaaS and PaaS, we actually have quite a lot of services, and to understand and to do a well architecture framework, you have to keep three things, or there are some foundational concepts or techniques which you need to follow. So following up, we have the techniques mentioned. It's good to remember secure architecture, secure development and configuration, and continuous monitoring and guardrail. So starting with secure architecture, its key principle for the security. How you design, how you define is actually very important. You need to have segregation of resources and networks, implement least privilege, ensuring secure storage, communication, and service configuration. More or less, we have covered some of these items like segregation. When I talk about you can have different VPCs set up for different services. You should not have everything clubbed into one. You can have one tier or one VPC for application or the front end. Then you can have a middle tier for the application and the database tier. Then you can also segregate your security in a different VPC. Secure deployment and configuration. Yes, as you deploy resources, the good thing about cloud is most of them is infrastructure as configuration. That means you can configure your resources programmatically. Okay. So when you actually perform any configuration, deploy anything, you ensure that they are hardened well in advance. It could be your VMs, containers, your networking. And all these hardenings are the security best practices or security benchmark. CIS is one of them. You can actually use their hardening guidelines. You can use vendors best practices to perform your hardening. Continuous monitoring and guardrails, very important. Uh, while when you are doing your implementation, those are the first two stages. Definitely, you have operations, which is a longest cycle ever after you do your provisioning. So you have to ensure that you continuously monitor them. On top of that, you have to do preventive and reactive controls. That means you can block different IPs or any configuration changes. That was a preventive. But let's say there has been an action or there has been an alert, there has been an event and the alert has been triggered. Then we can have a reactive approach as well. Okay. On top of that, you, as we discussed in the last domain, enabling logging is the key for all your monitoring, your performing your alert mechanism, your forensics. So those are kind of key. So what you see in AWS, to give an example, there are config rules, there are service control policies. So service control policies actually work as a guardrails, and config rules is actually something you can define as a uh, continuous monitoring or creating a baseline. So different cloud providers have different terms, but yeah, these three techniques, definitely remember them, will be very useful. Okay, so the infrastructure security actually starts from the cloud service provider. They are the one who give you the infrastructure, they give you the platform, and then customer is the one who is building resources or they are putting up workloads as part of the implementation. Okay, but the concept about SSRM, shared security responsibility model, still exists. But depending upon the kind of service you are using, IaaS, PaaS, and SaaS, definitely you have a different responsibility towards or managing the environment. But actually, it all starts from the cloud service provider. So there are things which you have to understand. I think this can also be used in audit, but this is very high level, but it's very important for you to understand. So the first of them is the facility. Facility is all talking about physical security. You have surveillance, you have environmental protection, how you perform access control, your access IDs, and could be the building where you're hosting your services and where are the servers hosted, housed. Okay. Then you have the employees. There are employees which are being hired by service provider to actually maintain this infrastructure. So definitely, cloud service provider has to perform screening, have to train them, manage their employee. You have to have trustworthiness and integrity within the organization so that the employees work accordingly. Then you have physical network storage and compute. Definitely, they have to uh, align with, I would say, different telcos to provide you network security. Then you need to have a sufficient amount of storage available. To give an example, there could be storage companies who are already building up storage devices. I have such an example. I have a friend working with which actually provides 36 terabytes disk uh, to different cloud providers, and then they actually use it. So that is when you are storing uh, huge data in a small form factor, which is around 3.5 form factor and then 36 TB. Okay, so this is one of the example I have, right? So they are the one, the cloud service provider are the one who actually support your physical computation. So whatever the physical servers devices, they are the one providing you. They add a virtualization layer, which is actually the the core of the the environment. When you say platform, that is what we are actually, or the cloud service provider is actually providing you, but the customer is the one who's putting up the workloads, but they actually help you to put up an isolation. That means the two tenants don't have the, even they have the shared infra, they don't interact with each other, right? Okay. Then you have a management plane, very key term, do remember that. So management plane is something which the service provider gives you access. They actually has like a web-based interface or an application APIs or the console. This point is when you manage your resources, okay, as a customer. This is the place where you manage your cloud resources and services, okay. Then you have PaaS and SaaS services. Definitely, they are high level platform where you have limited control. If I have to compare with infrastructure as a service, again, based on the share responsibility model, you can go back and check my other videos. They will give you a summary how does the IaaS and PaaS and SaaS services work under that. So, in a summary, CSP is the one who is providing you facility, hardware, virtualization layer, and management interface, while the customer is more focused on deploying onto that infrastructure. So, infrastructure resilience. When we are talking about cloud computing, the resiliency refers to that an application or system continues to run seamlessly. You're not the one who's bothered about how the infrastructure is laid out. That means the physical environment, the networking, and all that. What you see is actually an API, a web console, or a CLI console where you actually perform all your activities. Okay, so from a customer perspective, it should be seamless. That means in case you have a resource is accessible, that's it. But from a cloud service provider, their resiliency is much higher. They have to coordinate and work with different uh, network providers and all that. Okay, okay. So when you are actually performing your resiliency, there are multiple ways to do it. Okay, you can have a single region resiliency. That means when you start, you actually start slow and low. When I mean to say that is like you will start with your basis or basic environment or the minimal requirement, and then you grow as you move forward. Okay. With a single resiliency, you can have auto scaling, load balancing. How it works is auto scaling is scale out, scale in. That means, let's say you need more servers, it automatically provisions for you. But when the requirement goes down, it actually deletes. But the application has to be flexible. Okay. Similarly, then you have what you call load balancing. Then you have application which is hosted, and then you have multiple nodes, and then the load balancer will actually shift or distribute the load depending upon the service availability or the port or the configurations you have in mind. Okay, that actually to handle the spike in traffic. In order to perform any kind of put protection of the data, you have backup and recovery strategies. Where do you back up, how you recover them, and what are the components to that? That is something you can define. But single region deployment is quite vulnerable. It's a regional base, but if I see from now, even if I say Singapore, Singapore has got 3 AZ, and that means there are 3 different data center who are managing the entire region. So the possibility of a region going down is quite low, but yes, it could happen. There is nothing called as zero risk, but that could be a rare case. But if you want more resiliency, then you can have multi-region resiliency. That means I am setting up an environment maybe in Singapore and India and US together. Okay, the I can have parallel deployments of the application. The applications are multi-hosted and running from different locations. That's what I can do. On top of that, the challenge you will feel or face is to design your application. That's the first thing. That means when the traffic comes from X region, how it is routed, and to which region, and what will be the easiest path. So that comes to the edge network, but again, this has to be decided, right? Definitely, it requires change in the application, how it works, how the customer base is, and then on top of that, you have to understand uh, it does involve cost, right? Because you have multi-region and your application is dispersed, definitely your data is dispersed. So do you need localization of your data? Example will be if you have any compliance requirement that the data within Singapore does not go out. So in that scenario, how do you handle multi-region? Okay. So these are the design decisions you have to definitely understand. It improves your fault tolerance and geodiversity, but again, it introduces additional cost. The hardest of all is the multi-resiliency, which is based on the multi-cloud provider. Example, you have an application which you have initially implemented in AWS. Now you want to do a implementation in GCP or maybe Azure. Depending upon your requirement, how you want to do it, also depends whether you find some better services offering from other cloud provider and then you want to utilize it. And then maybe you can have a production and DR strategy, maybe production running on AWS and your DR is running on another cloud provider. So these are some of the factors which you have to think through. But again, within the same cloud provider, definitely the services are common, the configurations are common. But when you go next stage, putting up a multi cloud, then you have to understand whether you your design is has done sufficient checks, and then resiliency will be increased definitely. But transparency among the application should be higher as well. Okay, what we can achieve is containerization. Containerization will be abstracting the application from the underlying infra. That means you don't rely on the infrastructure. What you have is you have pre-packaged an application which can be just run on any format, and that reduces the challenge, but there is still a challenge how you host, because you still need an infrastructure. Then there is a workload which you want to spread across different cloud provider or different region, and definitely the cost can definitely escalate, and it could be an operational expense. But this is, I have seen a way moving forward, where people are actually trying to move towards containerization and decoupling their application from the infra, and that's actually giving them other benefits. Then the services have also stepped up, and then they are providing you with more benefits. So all in all, infrastructure resiliency, do note you have single region, you have multi-region, then you have multi uh, cloud provider, then so all these combinations you have to think through when you're performing your design. Fine, though this is again, you will hear the word SDN, software defined networks. Always remember that it's kind of it could be a buzzword, but now I can see that this is something which is being used heavily, and definitely all the cloud network is based on SDN. That means you have a separation between the customer tenant environment. Okay, then this is mostly you're defining your network programmatically. That means you can just deploy it via code. So as we move forward, I think there are a couple of things which I want to cover. There is a specific slide which talks about software-defined network. So let's move forward first and then cover it. Right. Software-defined networks, SDN, you will hear this term. So what you are doing is decoupling the network control plane and the data plane. So I will explain what is control plane and data plane uh, quickly. Uh, what you have to understand is software-defined network is all about networks, but network, there is no physical device involved. everything is defined programmatically. That means you have a firewall, which is kind of an appliance. You have a WAF, which is also an appliance. You have switches, routers, everything. So they more or less they perform the same function. It's just it is a logical entity rather than something a physical entity. Okay, so that's what the software-defined networking is. So talking about the control plane is actually where you're controlling how the routing happens. Okay, how the routing happens when you talk about the packet coming in, how does the packet moves around. Okay, the data plane is about how the data or the between the resources and the network, how it has been moving, or it's actually about the data. So control plane is more about management, but data plane is actually hosting your actual data. Okay, that's easy to understand. So primary advantage of SDN is definitely flexibility and agility. You have something which you can rapidly provision, you can remove it, modify it, update it on a fly. So these are the key things and the benefit of that. And uh, it's usually default in any of the IaaS provider. So SDN, as I mentioned, is in any network is a deep by default. So uh, on top of that, customers that are not managing their individual components. To give an example, let's say you are using a PaaS or a SaaS service. Okay, you are not the one managing your network component, or it could be let's say the edge networking. So most of the customers are provided with what you call a WAF, okay, which can be a front end like CloudFront in AWS or Akamai. So they are being provided, they do the basic DDoS protection for you. So similarly, these things, because they are logically defined, kind of easy to manage and easy to run. As a customer, you just have to be logically grouping all your networks. That's it. So kind of important, why I put the word important there. These eight terms: VPC, which is virtual private cloud; subnets, public and private; routing tables, cloud network security groups; ACS, load balancer, internet gateways, endpoints. I have actually slides number 8 and 9 moving forward to explain all of them. What are the use? What are the benefits? So kind of important. Do remember these terms. Do remember this term. Not for the exam, but definitely when you are into a discussion, you're performing an audit. These are the words which are actually sometimes thrown by the technical team. You don't have to do deep dive, but you have to understand what is the use of a virtual private cloud, how does a subnet work, what are the public and the private subnet, how to identify them, what are the classes, what is a routing table, why you need a routing table, why you need security groups, why you need to define ACL, which is layer 3, layer 4, load balancers, how they work. Could be an application load balancer, network load balancer, your internet gateways, you need a connectivity to the internet, how you do that. Then you have endpoints. So these eight of these terms I've explained in progressively. So let's jump in. Yeah. Okay. So first three terms, virtual private networks or called virtual networks. Then you have subnets and cloud network security groups. So start with virtual private clouds, VPC in AWS. They're actually groups of subnets which are logically defined, and then they have isolated virtual network. So you can create your resources, and they also helps the customer to have control on the network. So that means you can create a VPC. I think that's the first thing you create, and then with that you start setting up your environment, designing your network. Okay, again, it provides a security and private network environment. That means, as I said, you have private subnets, public subnets. So private network is the scheme which you use for all your internal resources. That's the use of a virtual private cloud. Talking about subnets, as I mentioned, public and private. There are subnets which are public, which are exposed to the internet. Then there are private subnets which cannot be routed to the public network, and it's only used to create your own environment. And you need a NAT to that. Okay, so what you have is subnets provide you for the segmentation. That means you can have one segment for, let's say, your uh, virtual machines. Then you have one network for your, let's say, security appliances. So it actually helps you to further segmentation and narrow down or focus area only to specific services. Okay, or you can group your resources within an organization using smaller subnets. That's the important thing. Ease of applying security policies, access control policies based on the network, very important. You will hear something as NAT, network address translation. This is more towards the outbound internet access. So let's say you have applications which actually uh, get thread feeds, or you actually have some home calling. That means in case the system has an issue or they're generating an alert, you have a managed services, you need to have internet connectivity, definitely you can use a network address translation. So what they do is they convert the private and the public network interchange. They means to share the packet, they give you a logical IP. So when the data goes out, it's converted to your proxy IP or NAT IP, and then it goes and talk to the internet. When it comes back, it's translated back to your uh, internal address, which is non-routable. Okay. Again, you have security groups. They are more of a stateful firewall, okay, but are implemented within the network fabric itself, right? So they are virtual firewalls with network interfaces and instances. Again, control the inbound and outbound traffic. You define IP, ports, protocol, very granular level security. When you perform a micro segmentation, they are the foundation. By default, everything is denied. So you have to explicitly allow to make it work. So these are the three key things you should remember. So the next three terms we have routing tables, cloud network ACS, and load balancer service. Routing tables, it is more towards how the traffic flows within a VPC. That means you have a VPC and how the traffic flows between the resources. And in case you have to perform a specific path, that means you have to reach to a network which is external, you can define how the routing table will be. You actually define routing table to have an optimal network performance. What does it mean is how your traffic flows will be the point A, point B, point C. So that way you know how to route your traffic so that you can take the logical path or the path which is quite easy to and will increase your network performance, right? ACS is actually more of something on a subnet and the networks level. When we were talking about security groups, they were actually apply to the resources like you have an EC2 instance. But when you talk about ACL, they're actually subnet and networks, right? And they're lower in the network stack than security groups. Definitely stateless. That means it doesn't recognize, so you have to define them, right? Load balancer, they spread traffic up across multiple VMs, or I would say it could be EC2 or something more or less you can understand as a web service. Okay, to give a better example, let's say you have a URL and then you have multiple user accessing it. You can have a round robin. That means you have three nodes, and the 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 access goes to node 1, node 2, node 3, and it keeps going in circles, right? You can actually also uh, define application level load balancer, network load balancer. And application load balancer will be more towards application related issues. That means, let's say the traffic is coming from XX application, where it actually talks about uh, a specific mobile application. And if it is using a mobile device, the traffic goes to certain nodes. But when it's coming from a desktop, it goes to a different. So you can define to that level. Auto scaling, one of the feature to fluctuate. You have a spike, or you have a sudden spike. How do you manage that? So maybe you can have an additional node, or you can distribute the load 60-20, 60-20-20. So you can actually do that. It's more of a service rather than a device. It's not a device. You don't think it is a device you have to implement, but it's more of a service, right? You enable the service, you configure the service. So it's more of like that. Okay. So there could be multiple availability zones. So even what you can do is you can have spreading or one load balancer that can spread to multiple availability zones. That's another way of managing it. It is foundation for other security devices, like I mentioned, WAF and DDoS. Okay, so let's say you have an application which comes in, you see the traffic is generated from one location, then you can actually define it or reroute it to the nearest edge, and then from there on it comes in. So this way you can control the traffic. So you can also see if it is a DDoS attack, or it can be stopped at the origin itself. Web application, this is more also geo protection. That means the traffic is generated from X country. You can either block it, allow it. So all these works based on a load balancer. So again, routing table, network ACS, and load balancer. Three terms. Do remember that. Okay, two more terms: internet gateways and endpoints. Internet gateway, as the name specifies, it's an entry and exit point for the internet access. You have a device, you need internet access, you need internet gateways. This is more on communicating to public internet. inbound and outbound internet connectivity to the cloud resources. Example could be a Bastion host, or I would say a better example will be EC2, where this EC2 has to fetch patches on a weekly basis, and then you need an internet access or call home so to download it. So that's where you need internet, and then you can use internet gateways. Endpoints is in case you want some of the services accessible over public IPs. So you can define private endpoints. You also have endpoints. You can expose your services using private endpoints. And at times, this is also possible and when you don't want to go through internet, then the CSP can actually provide you with private endpoints. That means your service is still available from the cloud provider, but it's not going through or through public internet. So it actually increases private endpoints. It's recommended by CSPs as they increase security and performance. The next part is about resource which are included. Moreover, you have management plane, which will understand workloads, storage, load balancer, and APIs. I think the next slide will talk about it. Fine. Next one is cloud network security and secure architecture. Understand there are two sections to it. One is preventive security measure, other one is detective security measures. Let's deep dive into preventive security measures, which include CSP firewalls, virtual appliances, and WAP. So CSP firewall, it's like an you have an Amazon network firewall or Azure firewall, and this is more into the cloud platform. uh, Advantage is not requiring additional instances or servers to be maintained. It's more, it provides you the first layer of defense. Okay. And you may have limitation in terms of customization because this is something provided by the service provider itself. You don't have a direct control on that. Next one is the virtual appliances. It's more the virtual firewalls which actually have a greater flexibility. You can deploy them from the marketplace, you can implement them, and then they work. Moreover, I give an example like Trend Micro. They have an IPS, IDS products, or you have Palo Alto, which is a next generation firewall. So this is all available, and you can deploy them as a virtual appliance, which you can configure from the management plane, and then this gives you a great flexibility. Again, they are deployed along with a load balancer. uh, the reason being so that you have a distributed service. So these are the benefits. WAF is moreover a web application interface towards the application. That means common exploits such as SQL injection or cross-site scripting, or maybe any one of the OWASP top 10. Most more or less they are covered. The WAF is covering most of these exploits. And again, this is also preventive controls. That means you can do the blocking, you can also do a learning, and then you can take an action on that. Coming to the detective security measures, flow logs and DNS logs, very important. I think most of the people get confused. More or less, people know about firewalls, appliances, and WAF. People don't know about how does the network flow and the DNS flow works. So network flow helps you to understand any anomaly. When I say anomaly, a suspicious network traffic pattern. That means you have a C2 or a command and control IP, uh, it's a way back where the access is happening, the data is moving out. So this is what you can use using the flow logs. Okay. The DNS log is more about requests and responses. You can actually have a different, you can actually export DNS data with recursive queries. So you need to have DNS logs monitoring in place so that you can perform this. Uh, Nowadays, uh, these, especially to give an example, like DNS logs, is actually to perform data exfiltration. So if you want, you can read about it. But yeah, for or less, I think these are very key terms, and I think you should make note of that. Okay, you can mark this slide. Infrastructure as a code. A lot of people don't understand. In the traditional environment you have physical devices, as we talked about software defined networks. So these devices used to be physical. Now they all are logically defined or virtually defined in the cloud infrastructure, and this all happens with the virtualization technology. So anything which can be created programmatically, or the infrastructure components that can be created programmatically, are part of infrastructure as a code. There's a special publication from NIST that says the process of managing and provisioning an organization's IT infrastructure using machine readable configuration files rather than employing physical hardware configuration or interactive configuration tools. So hence it is not physical, this is something non-tangible, and then you have to create it using a command line, using a scripts, easy to configure, easy to deploy, right? What are the benefits? Again, automated compliance check. You want to do a validation. You did a configuration, you deployed it, somebody changed the configuration. You can use the same script as a baseline to validate whether has any changes. Helps you to validate again any security standard, any regulation, any compliance requirement. Again, you have benefit of doing a consistent security posture because it's a software. You just have to write or validate the few lines of code that will become your baseline. With that baseline, you can actually define how we are deviated and also associated with the manual error, because let's say you are performing a deployment, you are troubleshooting, you made some changes, but how to do all those maker and checker positions. So what you can do is you can have these scripts. You can actually use the same script as a baseline and then run it across, do the compliance scan, and then you can check it. Rapid rollback. When they are so easy to deploy, if it is easy to deploy, easy to roll back as well. With some simple commands like install, uninstall, deploy, undeploy, you can actually use, and it reduces the overall complexity. And all this can be included in the change management process. That means within a cloud, you can define a workflow. Somebody wants to deploy a virtual machine, you give as a script, somebody goes and approve it, the deployment happens, it does a validation, it performs all the checks, and then it gives you an output in a form of a email or as is. Okay, now IAC is also a component which actually, as I mentioned, can be a workflow or deployed as a pipeline. So all you can define a CI/CD pipeline which can be used, or you can use it to create all your infrastructure. So why we are doing it? We are trying to do a shift left approach where you fail early, you find the problems early, so the progressive tasks don't have problems. It's more of a reproducibility and significant benefit to the security. Okay, again, another important term, zero trust for cloud infrastructure and networks. A lot of people get confused. They think zero trust is kind of a tool. I just go in the market and then get zero trust something. No, it's a strategy. It will be covered in Domain 12, but it is a comprehensive cybersecurity strategy. Yes, there are ways to implement it technically, but there are things which you have to understand, that what you need in order to implement it, or what exactly we are referring here. So whenever somebody says zero trust, it doesn't mean that it's something you have to deploy. It is a strategy. That means you have to define it. You have different layers, different components, and that makes it happen. So the first one is software defined parameter and zero trust network access. So these are the two technology terms which you can use, and how they work. Let's go and understand that. So you have software defined parameter, SDP. Actually, what you're doing, you are creating a network, which is a dark network, which is invisible to unauthorized users and devices. So when I say blackout approach, that means it's only visible to certain set of people. It is not accessible by default, inaccessible, inaccessible. Okay. Again, then you have users and devices. That means you don't trust anyone coming in, whether it's a user or a device. They have to authenticate and has to be authorized by the STB protected resources. Okay, before you access any SDP protected resources, you have to authenticate and authorize both users and devices. How it works? SDP has two things. One is SDP controller, SDP gateway. SDP controller is where you define your policy. Okay, this is a point or which actually validates on basis of their attribute how the decision is taken. SDP gateway is provides authorized user and access temporary. The word is temporary access to protected processes and services. That means once you connect, you perform your job. When you disconnect, you connect again, you have to go through the process again. It's not once you get an access, you will always be able to drive in. Every time you move in, come in, you will be authenticated and authorized. Zero touch network access, again, you are not using the traditional virtual private networks. They are more granular. You replace them with an access control model. Again, this is where the technology can come in. Okay, users are verified, authorized based on their identity, devices, and location. There could be other factors which can be used. Again, depending, the access is provided to specific application. It's not a broader range, but again, you have very strict authorization mechanism there. There are solutions available, technology solutions available, but they comprises of different tools and technology. That means you need to have a gateway, need to have a controller, the network has to be hidden, and all those things. So this is what makes a zero trust as one of the concept. It's a strategy. Okay, another term, SASE. Uh, I don't know whether I see something about it. It's fair new, fairly new actually. So it says secure access service edge. What I got out of this is definitely this is again a more of a concept which is coming in. I think it's talking about how your network functions with a wide area network and proxy capabilities. All in all, what I understand is it's an important element for zero trust architecture. When you are implementing a zero trust architecture, you need this. What you're trying to do is you are filtering all the traffic at the edge level. That means, let's say, uh, to the user device. Let's say you have a user is connecting. To give an example, Netflix. Okay, so actually, when they authenticate, authorize, you don't have to go all the way to access everything. So what you can do is they can be assist the client integrity, the authentication, authorization, all these things can be near to the user device. Actually, it helps you with the latency, and also it's bringing more filtering. The word is filtering to the edge. I think that's the key thing to understand. I don't have much on this, but I would suggest you to go through most of the slides. I think slide number 13, which talks about zero networks or zero trust network, is actually kind of very useful. Uh, uh, Overall, this is a bit technical domain, but it's good to learn. I would suggest go back and take the terms, jot it down, put it somewhere. It will be helpful for your career. Yeah. So that's all for this topic. I think good for domain 7. I will soon release all the other domains. So just stay tuned. Okay. I want to thank you again. So like and subscribe the channel, and I will be adding more videos soon. Thanks a lot.